Okay, sorry we got cut off in the middle of that problem. So we have solved the equation for y and rearranged it so it's y equals mx plus b form. So we graphed our y-intercept. So we put our point at +8 on the y-axis. And from here, we were calculating our other points by using the slope, which is 2. So a slope of 2 could either be a rise of 2 and a run of 1, or it could be a -2 over -1. Both of those would simplify to a +2. So from my y-intercept, I could go down 2 and left 1, down 2 and left 1 to find the rest of the points on my line. So that's how we can finish graphing part C. Let's look at part D. We definitely have some more work to do on this one because we need to first solve for y to get it in y equals mx plus b form. So I'm going to rewrite my equation over here so I have a little more to work. And I'm going to start by subtracting 3x from both sides to move my x term over to the other side of the equation. So on the left, I'm left with 6y, and on the right, I have -3x and a +18. So I'm going to put that in mx plus b form. And now I will go ahead and divide both sides by 6. So my 6's on the left side will cancel, so I'm left just with y, which is great. But on the right-hand side, I need to remember that I'm dividing -3x by 6. So -3/6 would reduce to -1/2 x. But I'm also dividing a +18 by 6. So 18 divided by 6 is 3, and it's positive, so I put +3 for my b, or my y-intercept. So now that's where I'm going to start my graph. I'm going to graph my y-intercept, which is a +3. However, looking at my graph, my scale, I'm counting by 2's. So 2, 4, 6. So that means 3 is going to be halfway in between 2 and 4. There's my y-intercept. From here, I'm going to go down 1 and right 2 because my slope is -1/2. So I'm going to go down 1, right 2, and put a point. Down 1, right 2. Down 1, right 2. But remember, I could also do a positive run of 1 and a positive rise of 1 and a negative run of 2. So again, starting at my y-intercept, I could go up 1 and left 2, up 1 and left 2. And I know I'm doing good work when all of my points line up in a straight line. So since I've graphed an equation, I can draw my continuous line through those points and put arrows on the ends. Our next example deals with identifying parallel lines. So for parallel lines, we know by looking at lines that they're parallel if they're always an equal distance from each other. But sometimes it can be hard to tell. So the best way to verify if lines are parallel is to check their slope. Two lines are parallel if they have the same slope. And if you think about it, if two lines have the exact same steepness and direction to them, then they're parallel. So we find the slopes of the lines and check them to see if they're parallel. So let's look at this example here. As I look at line A, I have 2 points here. I have the point -1, -1, and I have the point 2, 0. So I'm, for line A, going to find the change in y over the change in x. So I'm going to subtract my y values, 0 minus -1. And now I will subtract my x values, which is 2 minus -1. Notice it's really important to keep track of your signs here. So 0 minus -1 minus a negative, I can do same, change, change. And minus a negative really becomes plus. And in my denominator, I again have 2 minus negative 1. So I could do same, change, change, meaning I keep the 2 the same, but I change my next two signs. So that's really 2 plus 1, which is 3. So the slope of line A is 1/3. Let's check line B. I'm again going to find my change in y over my change in x. So I'm going to start with my first y value, which is -1 minus -3. Again, I'm going to have some same change, change. In my denominator, I'm going to take my x value minus the next one. So 5 minus 0. So as I simplify here, -1 minus -3, I'm going to do same. So -1 stays the same, but I'm going to do same, change, change. So I have -1 plus 3. My rule for adding a negative and a positive, different signs, I find the difference. The difference between 1 and 3 is 2. And my larger number is 3, which is positive, so my answer is positive. You can also think of it on a number line. If I'm at -1 and I move 3 units to the right, that takes me to +2. And in my denominator, 5 minus 0 is 5. So even though my line A and line B look like they could be parallel, when I find their slope, I actually see that they are not parallel. So let's check out line C. I'm going to calculate my slope doing the change in y over the change in x. So I will take my first y value, which is -3, and subtract from it -5. So I have -3 minus -5. And I will subtract my x values now. 4 minus -2. So now to simplify, I'm going to do same, change, change. -3 stays the same. Minus a minus becomes plus a positive. And now I'm at -3. If I move 5 units in the positive direction, that brings me to +2. And in my denominator, I will again do same, change, change because I'm subtracting negatives. So the 4 stays the same, and I change the next two signs. So 4 plus 2 is 6, and I can reduce this to lowest terms. And I do see now 2 lines that have the same slope. So line A would be parallel to line C. But the only way to know for sure is to check the slopes. So sometimes you will have to tell whether the graph of the two equations are parallel lines, and we're just given equations and not the actual graphs themselves. But we know now how to quickly and easily find the slope of a line just by looking at the equation. So if we remember in our y equals mx plus b form, that m, my coefficient of x, tells me the slope of the line, I can merely look at the equations and tell you whether the slope is the same. So on part A, y equals 8x minus 3 is already written in slope-intercept form, but 8x plus y equals 3 is not. So I'm going to have to rearrange this one by using inverse operations. So I'm going to start by subtracting 8x from both sides, and that gives me y equals -8x plus 3. So now I have two equations I can compare, and the slope of my first equation is +8. The slope of my second equation is -8. So for part A, no, these lines are not parallel to each other. They don't have the same slope. On part B, same thing. Let's get these equations into slope-intercept form. So I'm going to have to rearrange 2x plus 4y equals 5. So I will subtract 2x from both sides. And that gives me 4y equals -2x plus 5. And now I will divide both sides by 4, remembering that I need to divide negative 2x by 4, and I need to divide 5 by 4. So my final equation would be y equals negative 1/2 x plus 5/4. Now I can look at this equation in slope-intercept form and look at this equation in slope-intercept form. And I see that my coefficient of x, that m term here, is negative 1/2. And here it's negative 1/2. It doesn't matter that it's decimal version and fraction version, the value is the same. So these lines would be parallel. Last but not least, let's check out letter C. I'm going to use the same process, and I like my first equation because it's already in y equals mx plus b form. But my second equation, I'm going to have to change it up a little. So I'm going to add x to both sides, and I get y equals 3x plus 7. Now I have two equations I can compare. The slope of my first line is 3. The slope of my second line is 3. So yes, these lines are parallel. All right, you are ready for your homework. It is your 4.5 worksheets. I have the numbers circled on the worksheet for you, but you're going to be doing numbers 1, 3, 5, 7, 8, 9, 11, 12, 13 through 21, and then also 23, 25, 27, and 31. Good luck, you guys.